we have, it says find the point on the curve that is the closest to 3, 0. Okay, so here's our square root of x. And the point 3, 0 is here. And this is the square root of x. So we're asked to determine the point on this function that is the closest to 3, 0. I don't know where that point is. And I don't care. I need to look at the generic value. So let's say, of course it's not. I'm exaggerating. I'm going to say that this is the point. It's not. It's probably somewhere here. I don't care. It has to be generic. I don't know where it is. But I know that this point has coordinates x, comma, this, maybe this is not the best though. So the point here, x, comma, the square root of x. I need to minimize distance. But I have to remember that the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So then the distance is x minus 3 squared plus, so x minus 3, the square root of x minus 0 squared, but it's just the square root of x squared. That's my function. I can simplify it a little bit. It's the square root of x squared minus 6x plus 9 plus x squared. So this will be the square root of 2x squared minus 6x plus 9. I got the function. I want d prime of x, which is 1 over 2 the square root, multiplied by the inner function prime, 4x minus 6. D prime of x is 0. It cannot be undefined, because if this is 0, the whole distance is 0, and that's not possible. And just this, the numerator. 4x minus 6 is 0, which means x equals 6 over 4, or better, x equals 3 over 2. So the point, I'm going to come back to my graph, I'm going to call it P. So point P has coordinates 3 over 2, comma, the square root of 3 over 2. But you have to say, show me. You haven't. And that's true. I have not. I have to prove to you that this number, 3 over 2, of course it's not infinity, gives a minimum. Okay. Well, this is all positive. I'm not going to waste my time to even look at it. But this is a linear function that has a positive slope from negative to positive. And that will give the sign of the derivative. Definitely a minimum. So the point, I don't know where it is. I can find the square root of 1.5. Square root of 1.5. 1.22. So the point is P 1.5, 1.22. So 1.5, 1.22. As expected. This is the point on the graph of the square root of x that is the closest to 3, 0. But I have to choose a generic. I perform the operations, I create the function, etc., 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 and I find out. So the coordinates must be 1.5, 1.22 of this point, which is the closest to the graph of the square root of x.